So being we have a limited amount of people here, let's just kind of run through this, and then I'll just assign you the rest of 4.4 to work on, and then we'll get this chapter finished up. We've only, if you look at the thing, we have 4.5, which is called a Venn diagram, which we'll do tomorrow, and then 4. We skipped, for some reason didn't have 4.6 in there, so we'll go to 4.7, and then review, and then test on or test or quiz or whatever we're going to call it on Friday. Cool? All right. So page 207. So they have this table that they have. So they have eye color and they have hair color. That's the titles of each. So you have brown eyes, blue eyes, hazel eyes, green eyes, and then whatever the total would be. And then hair, we have black, brown, red, blonde, and then the total. And so they just fill this out. Let's see, it was, we have 7,221 for a total of 12 here. And then brown, we have 12. I think that's an 8. There we go, that's nicer. 12, 8, 5, 5. So then we have a total of 28 people of these. And then we have red, we have 3,211, which is 7. And blonde, we have 1,912, 13. And then if we total it across, there's 23 people with brown eyes, 21 with blue eyes, 9 with hazel eyes, and 7 with green eyes. And then the total both ways, so the total going down and the total going across is 60. Okay, so we're able to start answering the questions now. So we want to know problem number 1, probability the person has blue eyes only. Okay, so blue eyes would be 21 out of a total of 60. Problem number 2, they want to know the probability somebody has red hair. So this is eye color. This is hair color. So red hair, there's 7 people out of 60. And then number 3, they want to know, do they have, person has green or hazel eyes. So green or hazel, let's see, green or hazel, so you have 9 plus 7 out of the 60, so that's going to give me a 16 out of 60 chance of me drawing somebody out. Okay, and I'm on page 207 for those of you needing to find the page, 207. All right, problem number 4. We want to know, does a person have blue eyes or blonde hair? Okay, So this is one that we have to be cautious on. So I'm going to highlight this one in yellow. So blue eyes is this region here. Blonde hair is this region here. So what do we have to be careful with in this situation? Do what? Yeah. So I can count the 21 going across, no problem. Okay? So if I get the 21 and I get the 13, but I have to make sure I don't double count that 9. So I'm going to subtract a single 9 from it. Okay, that's basically the math that's taking place. Okay? So problem number 4 looks like blue eyes. Blue eyes, we got 21, right? So 21 and 13 is 34. 34 minus 9 is 25. So I have a 25 out of 60 chance. You see how I didn't double count the 9 twice? I subtracted a singleton 9 from it, so that's kind of important to see. Number 5. The probability that the person has blue eyes and blonde hair. So if I highlight this, with green, blue eyes and blonde hair is this right here. It's only that 9. Okay, so it's the intersection of the two events. So I have a 9 out of 60 chance of drawing that person out. Okay, does this make sense so far? Again, this is where the table is going to make sense. If you had highlighters, it's going to help you out. All right, let's see. Number 6. Number 6, the probability that the person has brown eyes and brown hair. My pen is getting lagging on me. All right, so let's highlight this in blue. Brown eyes and brown hair, it's this person here. That's all we're worried about there. So that gives us a 12 out of 60 probability of drawing them out. Number 7, what is the probability that we have brown hair such that the person has brown eyes? Okay? Okay. So this is what this means. They have brown eye color has to take place. So we're using this here as my denominator. And then they have brown hair. So that becomes a 12 out of 23 probability. That was in pink. Okay, so notice I didn't do it out of 60 that time. We basically, how this kind of thing is going to take place is what they're going to do is you have let's say you had all these 60 people in one room, and we told everybody with brown, everyone with brown eyes to stay in the room. Everyone else has to walk out. So you have 37 people that are out of the room now. There's only 23 people sitting in the room. What's the probability that we draw a person out of that group of only 23 that also have the brown hair color? Okay? That gets a little trickier sometimes. All right. Bless you. Bless you. Number 8, we want to know the probability that they have hazel eyes such that they have black hair. Hazel eyes, black hair. Okay? So, black hair. Let's do the highlighter. Oops. Highlighter. Pick a different color. Pick red. So we're going to do this one in red. Okay. We want the black hair. So it's this group here. So this 12 will be my denominator. So this is the same thing. You have everyone back in the classroom. Say, okay, everyone with black hair, stay here. Everyone else walk out. So you have 48 people that walk out of the room. So then we want to know the probability that they have hazel eyes. So that's 2 out of 12 probability. So you're being selective with your group. Problem number 9. What's the probability the person has red hair? Such that the person does not have brown eyes. Okay. So, gotta be a little trickier with this one. Let's go. So do this. Okay. Do this one in purplish. Okay. Not. Okay, we want to have red hair. Red hair. Okay. And they don't have brown eyes. Red hair, don't have. Okay, so what we're doing here is we have everyone in the room. We told anybody with brown eyes to leave. Okay? So we tell the people who have brown eyes, leave. So 60 minus 23, I believe, is 37. Do you understand how I just did that? So we're saying that they don't have brown eyes. So everyone's in the room. Hey, everyone with brown eyes, get out. Now there's only 37 people left in the room. And then the person has red hair. Red hair. Where is my... The person has red hair and does not have brown eyes. So we're talking about oops, wrong one. Highlighter. Purple. So the person has red hair, but they don't have brown eyes. So I'm talking about this person, and this person. So 2 plus 1 is 4. So I have a 4 in 37 probability of drawing them out. And then problem number 10, squeeze down here. What is the probability that a person has red hair such that they have brown hair? Hair. Okay. So in this thing, can a person have red hair and brown hair? No. No. So we have a 0. And then if we looked at this is like we're saying, hey, they have to have brown hair. So I have a 0 out of 28, which just would be 0. Okay, I'm not worried about the red hair column as well. Okay, So there's kind of an awful lot to look at on that graph. Agree? But I think it's useful when we're taking a look at it. Is there any questions on 1 through 10 on how we did it? And again, I think having the grid to look at makes it easier to understand than if we didn't have the grid to look at. Okay? Can I move on? Okay, so then they want to know for number 11, are black hair and hazel eyes mutually exclusive? So black hair and hazel eyes. Now, so what you do on this one is you take a look at your graph. Is there, if I went to the black hair aisle here, are these the only people who have hazel eyes, or do hazel eyes also occur in other ventures? And I think they occur, you can have brown hair, red hair, and blonde hair and have hazel eyes. So are they mutually exclusive? No. Because a person can have hazel eyes and they can have brown hair. People in our group can have red hair and hazel eyes. They can have hazel eyes and blonde hair as well. So they are not mutually exclusive. No. Can have hazel eyes and other hair color. Okay. That also, a person can have both. So that also falls into the characteristic. So being there's an overlap, we can say that, or we can say they're not mutually exclusive because they can have that combination, but they can have some other combination of either black hair or hazel eyes. So they're not mutually exclusive events of each other. Number 12. Are outcomes black hair and brown hair complementary? Black hair and brown hair are they complementary? Okay. No, they're not complementary because we have other hair colors that exist. So they're not complementary. Other hair color exists. Okay. All right. And then 13 should be pretty quick. What's the probability of brown eyes? So there was originally 60 people in our event. And if we go back to it and say brown hair, probability, oh, brown eyes, brown eyes. Brown eyes, there's 23. So we have 23 and 60 chance of pulling somebody who has brown eyes. Okay, so that's A. For B, we have probability of brown eyes. Such that they have black hair. So the black hair is going to be our denominator. So if we look back, black hair is 12, and brown, the people, so we take everyone, it says, if you have black hair, stay in the room, everyone else leave. So that means that there are 12 people, and there are 7 that have the brown hair. So 7 out of 12 probability. And then letter C, what does our answer say about the outcome of brown eyes and black hair? So brown eyes. So again, we're looking at this group. Brown eyes, black hair. So a person is more likely in our group to have brown eyes if they have black hair, because we have 7 out of 12 chance of that taking place. So it's more likely if we had people, we kept it, the people with black hair in the room, the probability of those people with black hair in the room have brown eyes happens more often than anything else. We have 7 out of 12 chance. That means there's 5 other outcomes that could take place. So that's basically the long and the short of that. Okay? So I want to give you guys the rest of the period to get page 208 all done. It looks like it goes from number 14. It's just do the numbering's weird on page 208, so just get the whole rest of that page 208 done. Deal? And we'll put that in tomorrow. Being that you're here today, I'm going to